All right, let's talk about the hidden magic that makes the internet actually work. I'm talking about the secret weapons, the clever tricks that let your favorite apps handle a truly insane amount of traffic without, just exploding. I mean, have you ever really stopped to think about that? How can a single app, a social network, a big shopping site, whatever, serve literally millions of people at the exact same time? The scale is just staggering, and yet we expect it to be instant. So how on earth do they pull it off? Well, the answer, and you're going to love this, is actually based on some surprisingly simple ideas. The core concepts are the same ones a really smart bouncer would use to manage the line at the hottest, busiest nightclub in the world. And trust me, this analogy is going to make everything crystal clear. So first things first, let's talk about the most basic tool in our bouncer's toolkit, the one you've probably already guessed, the VIP list. In the tech world, we call this caching. It's really simple. You just keep the information you need all the time in a super fast, easy-to-reach spot. That way, you don't have to go digging through some slow, clunky database every single time someone asks for it. It's a shortcut, plain and simple, and it's absolutely fundamental to how the web works. Just think about it, right? Our bouncer has two choices. Every time someone shows up, he could get on the walkie-talkie and call the club manager, who is our database, to ask if this person is on the list. Can you imagine? It'd be painfully slow, the manager would get super annoyed, and the line would wrap around the block. Or he can just glance down at his clipboard, the cache. It's right there. It's instant. The line keeps moving. And in this business, speed is the whole game. But, okay, this VIP list isn't perfect. Things can definitely go wrong. Like, what happens if the manager adds a new VIP, but the bouncer's clipboard is from an hour ago? That's called cache invalidation. And what if the VIP list gets so long it doesn't even fit on the clipboard anymore? Well, you gotta kick some names off the list. That's cache eviction. And what if you have like 3 different entrances? You've gotta make sure all the bouncers have the exact same list at all times. That's cache coherence. See? It gets complicated really fast. So given all those problems, what happens when the club gets so popular, so massive, that even a perfectly managed VIP list just can't keep up? Well, that's when you have to stop working harder and start working smarter. Because at the scale of the modern internet, you literally can't store and check every single piece of information perfectly. There just isn't enough time, not enough computer memory in the world. So engineers do something fascinating. They make a trade-off. They give up a tiny, tiny bit of perfect accuracy in exchange for a massive boost in speed and efficiency. And this is where these amazing things called probabilistic data structures come. Let's look at our first clever trick. We're going to call it the instant ID check. The technical name for this is a Bloom filter, and its job is really simple but incredibly powerful. It tells you almost instantly if something, like say, a username you want to sign up with, is possibly in a giant list of other usernames. Now here is the magic of a Bloom filter. It makes one rock-solid, unbreakable promise. It will never, ever tell you something is not on the list when it actually is. In nerd speak, that means 0 false negatives. So, back to our bouncer. Let's say he has a special scanner. If that scanner beeps and flashes red, it's a hard no. That person is 100% absolutely not on the list. No need to call the manager, no need to double-check anything. They're just out. Think of how much time that saves. It filters out all the definite no's in a split second. But, and here's the trade-off, it might sometimes give you a false positive. It might say someone is on the list when they really aren't. So if the scanner flashes green, our bouncer knows, okay, this person might be on the list. Now it's worth my time to do the slow check and call the manager. So you see the genius here? You avoid the slow, expensive check for all the definite no's, and you only do it for the maybes. And you see this everywhere. When you type in a new username and the site instantly tells you it's taken, that's probably a Bloom filter. Web browsers use them to check against a massive list of malicious websites. Recommendation engines use them to make sure they don't show you the same movie you've already watched. It is an absolute powerhouse of efficiency. Okay, so Bloom filters are great for yes or no questions. But what if our bouncer has a totally different job? What if he doesn't care who is in the club? He just needs to know how many people are here or how popular something is. Well, for that job, you need a count min sketch.
It's specifically designed to give you a really good estimate of how often something is happening in a huge, fast-moving flood of data without having to actually store and count every single event.
This is basically our bouncer's little handheld clicker counter. It takes up almost no space. But here's the interesting part about how it works. The bouncer might accidentally double-click sometimes, meaning his final count might be a little higher than the real number, but he will never miss a click. His count might be an overestimate, but it will never, ever be an underestimate. And this is absolutely perfect for the internet. How does a social media site know what's trending right now? They use this to estimate it. How does an e-commerce site know which products are suddenly flying off the shelves? This is how. It's for any situation where a pretty good estimate, instantly, is way more valuable than a perfect answer that shows up an hour later. So when you put it all together, what's the big lesson we've learned from our nightclub bouncer? It's really all about the hidden genius of being good enough. Let's just do a quick recap. Caching is the VIP list, where you trade perfect up-to-the-second data for blazing speed. The Bloom filter is the instant ID scanner, where you get 0 false no's in exchange for a few false maybes. And the Countmen sketch is that little crowd clicker, where you get huge memory savings in exchange for a slight chance of counting a bit high. Every single one is a brilliant trade-off designed to handle a scale that is otherwise impossible. And that kind of leaves us with a bigger thought, doesn't it? These aren't just tricks for computers. They're a mirror of how we deal with information all the time. In this non-stop, high-speed world we live in, just think about how often we're all making that same trade-off, giving up perfect accuracy just to get a good enough result right now. It's everywhere when you start looking for it. Thanks for watching.